So here we have the testing of lathes according to Schlesinger, description here. These are primarily the same as Myford has used, and they made their own here. And I followed those tests, so I made the, if you go through them here, the tailstock way alignment, max reading along length of bed. I've done the spindle center runout. I've done the spindle nose runout, so you can watch on video, and on the cam action of spindle you can watch on video. The total indicator reading at the spindle nose and at the end of the test bar. The headstock alignment, vertical and also horizontal. So you have a little bit high at the end and towards the tool pressure. It says here, for instance, at the end of the 6-inch test bar, up to 6 10,000ths high. So I've done the tailstock spindle alignment horizontal, and the vertical of the same, and the taper alignment, vertical and horizontal. You can watch some of these on video. And the vertical alignment of head and tail centers, both I'd also done it on top. Those are also very good, actually, within half a hundredths of a millimeter. Yeah. So 2 10,000ths actually, wrote for. Leadscrew cam action, that is adjusted so that it is equal, and then of course the main thing being that it should run free. The cross slide alignment, also facing concave a little bit, up to 1/100th of a millimeter on the 7-inch faceplate. The faceplate runout test I didn't do yet. That's primarily the same, but of course I will face at faceplate first and then do that test. The work mounted in chuck on video actually turned out within 1/100th of a millimeter. Very good, I think. And then all these, this I haven't done yet, but all these other tests I've done, and the bed is flat and in alignment within 1/100th of a millimeter or better. Actually I would say 1/2 from end to end. So these tests are all good. And this test is called the cam action of spindle. So you indicate to the face of the spindle and rotate the spindle. Good. Same test, but on the spindle itself. Also good. Yeah, should be roughly within 1/100th of a millimeter, which is little bit less of that. I'd say this is within that. So this is the top of the test bar, and I move it, goes actually a little bit below and up again. And it's within, I'd say 3 10,000s there. Went a little bit the other way, so, but it's up. So let's say within 1/100th of a millimeter up. That's also okay. And then it's the test from the front, which of course should read 0, but can also read a little bit towards the operator, I mean to compensate for tool pressure. So if I 0 it here, go in, there. Now I move it to the side. It goes a little bit towards the operator, yes. See? So I'd say that is 5 10,000ths, or a little bit over 1/100th of a millimeter, which is okay. And the spindle taper runout. Okay, so I'd say it is 1.5 hundredths, which is 6 10,000ths, which is also okay, at the limit, but okay. And this is another test of the accuracy of the lathe and its ability to turn or to face. And it says in the spec sheet that it shall face concave up to 5 10,000ths of an inch at 3.5 inch out on a 7-inch faceplate, that is. So if you think about it this way, I've clocked in this reference here so that it end to end measures the same, so to speak. If we go out here just to 0 and rotate, I have 0. And then when you face concave, that means that if you have 0 here, then that when you go inwards, and I am in metric, so I'd say 1/100th of a millimeter. It's a little bit shy of 5 10,000ths. So I go towards the center. And it's, well, it's less than that also. Could be a little bit, as you see. So go back again. Yeah, it's roughly 1/100th of a millimeter. As you see, in that direction. So all good. And the way that I have adjusted is by scraping on the rear here, and as you see, I tried to also to relieve the middle a little bit. I've liberal blue on now just to show, but this is how quite simply you do that. I think that Myford also did it that way. They could have done it on the longer way here, but anyway, that's the way I did it. And this is one of the accuracy tests for the lathe. So it should be 0 to 2 to 300 millimeter higher at this end to travel along the length here. So I've zeroed the indicator at this end and I move it. And it went up by 1/100th of a millimeter. The full travel here. So we'll go back and just check that it repeats. And it does. That was one test. And this is the same test as, longitudinal feed. I mounted the camera from pointing downwards at the rear of the machine, so this is pressure towards me here. I can of course adjust this error out, but this is a proof that the longitudinal, let's say, axis, I adjust it there, is okay. And this is also a proof on the cross slide feed. I set it up with backlash around 2/100th of a millimeter. So I run towards the tailstock. As I said, this error, if any, can be adjusted out, and now I'm using the hand wheel. And I am at 1/100th of a millimeter. There. So, and that was to the rear, but it's within, 1/2 and I can of course adjust this out by adjusting the screws at the rear here. So that also proves within. And this is another test for the tailstock, saying that the tailstock barrel, the travel along the barrel shall be from 0 to 0 and possibly a little bit up, like 2/100th of a millimeter up. Within that, it shall not dip below 0. That we allow, then we allow for a little wear and put it so that it goes a little bit up. So we run the indicator here, and it's roughly 1.5 higher here. So that's okay. And the same test from the side. I had to run this from the front because there's a slot in the rear here, but it shall be 0 here and pointing towards tool pressure, so pointing a little bit towards the operator when we move to the headstock. So I apply pressure, so that means that plus is this way, and then I move towards the operator, so it goes a little bit plus, so around 1 to 1.5 to me, so that's okay. One of the accuracy tests
that you need to perform, and also part of the restoration, is to ascertain that the lead screw doesn't bind. That's one thing. That anything is smoothly set up again, and that it's level, so to speak, measures the same when you indicate it on both sides, both on top and inwards, or in that plane and that plane. For some reason, this side was, let's say, roughly 12, 15, 20 hundredths of a millimeter. That is, let's say, maximum 2/10 of a millimeter too high here. And the design is such that it uses screws here plus pins. Pins, of course, locating the position, and screws to fixate it. So when doing that, I found out, okay, it didn't fit as good as I thought or wanted. So what to do about that? At least my take on it, based on what I've learned, and also in this case a little bit special, I modified the screws a little bit so that the section that in the middle here was really made a little bit smaller. I turned it a little bit smaller, also the head, and also I opened up the hole a little bit, so the hole was a bit, or the fit was a bit sloppy. And then I took out the pins. I indicated on both ends. When I was satisfied that this was level in that direction on top, or in that plane, I then snugged up those, tightened, certain that the measurement is correct, and then until I had a really good tight mounting. And now I will drill them out. This is a kind of a strange video, but I'm looking down into the mirror. So this is a mirror on the bench, and I'm indicating on top, but because of the scale being upside down, I use the mirror. So I just running the indicator back and forth, finding the highest spot on the screw, and zeroing the indicator on top, and then I move the saddle over to the where I want to test it again and measure. So thereby I ascertain that so let's move over. That the screw on each side has the correct height. That is, so I just finding the top of the screw again. I found that method easiest. So you see, I'm a little bit off there. So I need to take the screw a little bit. Let's see, is it, yeah, up? But it's, I mean, the pressure is minute. So anyway, that's the trick. And the method I use to locate the lead screw in that direction, same as on top, using the mirror, this upside down, locate the top of a thread instead of can't go that way with the indicator. I just go in until I hit 0 here, or some amp pressure, and then find the 0. And say there, and then I set 0 here, so now they match. I go out, I go down here, and I do the same. I find the top of a thread, let's say there, and I go in until I have 0 here, and then I should have 0 there. So it's a little bit shy of that, not much really. It's within, say, 0.02 of a millimeter, which I say is pretty darn good. Otherwise, of course, what you do then is that you just shim out or take off material. The main thing is, of course, that you have no binding at all, so it's loose. And then the turning test, the 2-color test. See. First I just run it manually. Now I engage the auto feed, feed a little bit in. There's a slight chatter, there's overhang and well, okay. Okay, satisfied. Now we can mic those. So
Seems to be okay. Yeah, within 1/100th of a millimeter. That is pretty good, I think.